After a very, very energetic beginning by Dr. Krishnan, I think after that the youthful Ajay did not let us sleep. So today my presentation is on FFS, RLA and structural stability. Okay, these are elements in asset integrity management. We'll see how it fits in the overall scheme. Yeah, okay. Can you hear me? Yeah. So, please, just keep moving. My presentation is with a very small introduction on HPCL, then asset integrity management, followed by the three elements I talked. These are the three parts I will be dealing with. Fourth one is not written. I will talk about that in the end. Please. So, HPCL is a Maharatna company. We have two refineries in Mumbai and Vizag. Third one is coming up in Rajasthan now. We also have joint venture companies with Methyl Energy in Batinda and MRPL in Mangaluru. These assets are our refining assets. Apart from that, we have a corporate R&D center of excellence in Bengaluru. Next. Typically in a refinery, you have this many assets that need to be monitored and integrity maintained. Next. This is a textbook definition of asset reliability, integrity management. During the service period, we do that to ensure the intended benefit, ensuring safety. And FFS, RLA and RBM are all integral parts. So the first part I will be dealing with is FFS, how we used in the refinery through a case. I think we had earlier detailed presentation on FFS from ProSim. They have done excellent thing. So this is a procedure that we follow. API 579 deals with a structured way of how do we do FFS. See, the level 1, level 2, level 3. Level 1 is a plant level, we can handle it. Level 2, level 3 are more complicated and expert experience in handling those things. We will be taking those services from outside, but knowing these things is very well useful for the owner to take a business call. Next. These assessments, FFS assessments, are used for run, repair, replace decisions, depending on the magnitude of what is the damage that has occurred in the asset. So there are 8 steps that are given in the systematic API 579, starting with flaw and damage mechanism identification, followed by knowing the applicability and limitations. They are also detailed in each part that is there in the code. There are about 13 damage mechanisms that have been identified there. Then the data requirements are also delineated. Then assessment techniques and acceptance criteria. This is very crucial, fourth one. Fifth, we have to do remaining life assessment also in some cases. Then the remediation for the damage that is there to ensure the future damage does not happen. And in-service monitoring is the most important case. In case of, let us say, remaining life and all, or even the assessment we find, it becomes very complex to take decisions. You may have to more critically, you cannot stop usage of the asset, nor you can allow it to run like that. So, your interventions in inspection become more important for the step 7. And step 8, I think morning, our distinguished speaker from EAL, Mr. Vartika, also told, documentation is the most important part of any inspections that we do. Next. So, you just go back. There is a small case. No, go back. Go back to the presentation. If you escape, you can go to the beginning and come forward. If you are not able to go forward, back in life, go forward. That's what I say. There is a small case study that we have done. What is presentation? Can you access it? Yeah, it's no, that is okay. Again, you have to go back to come forward. No, it is there. You missed it. It's come forward again. This is not counted, huh? Sir. This, that right. Not working. That means yes, that is correct. Yeah. Go back. There are. It's after this is coming up. I think that this thing is not copied. Attachment. No, he is not going there. Go. Click that. Yes. Here you hold. So as I mentioned, these are the levels of assessment we do. Level 1 assessment, if it passes, it is done generally at the plant engineering level itself. Based on some NDTs and visual inspection, we clear it ourselves. But if it fails in level 1, we need to do a level 2 assessment, which needs some experience and knowledge of the subject. Further complicated is level 3, where FEA analysis and all, which morning our person Ravi has shown. Raghu Prakash has shown. Next. This is the decision tree for going from one level to other. Next. Here, we are not going to our case. Come. Just leave it. These are the parts that are given in the code. Each part's applicability and limitation also is very well given. We have taken an example of a typical case where we have done. Go to the example, please. Yeah. This is a fire damage case we have done, in which first it was after joint inspection, we found the applicability of part 4, 5 and 9 and 11. These 4 parts were considered for this evaluation. It cleared part 4 and 5 with respect to visual, all those NDTs, corrosion levels, everything is found good. So level 1 it cleared with respect to corrosion losses, local and general. Then crack-like flaws were detected in the examination. Then these were further checked. As per the code, they were all meeting the requirement. The flaw is only lack of fusion, and it is not likely to propagate further. So it cleared that also at the level 1 itself. Next. Then we went to level 2, hardness, visual examination, microstructural examination. Microstructural examination, the temperature range indicated is between 650 to 700. This is not acceptable for level 1 assessment. Heat exposure zone is the temperature is 6. So we need to do a level 2 assessment. Next. This is the zone 6 highest. Next. So all the go back. All the equipment or various equipment were there in the zone, were in different zones. Next. So then we carried out dimensional measurement, no significant OD increase, hardness is also okay. Then hardness is converted to UTS and all these calculations were performed. This is a available stress at the fire damage case is much lower than the what is the available hardness at the UTS length. This also cleared. Next. But that is cleared at level 2. Then we did MWAP calculation for the this thing, fire case. The corroded area, damaged area, new area is using the PVLite software. All the pressures are coming much higher than the design. So equipment is acceptable at level 2 and it's also not operating creep temperature range. With all these things, this equipment is cleared at level 2. All the equipment we have performed similarly. Next. RLA is done. The rates were calculated, corrosion rate, and 8 years was considered, and it was passing. 8 years is 2 turnaround cycles we have, major interventions. So it, remaining life was more than 8 years is given. Next. Finally, TCR is the company which did it. For the entire thing, they have given clearance subject to paint restoration and hydro test as per the OEM process. Next. Finally, the structure also we have carried out structural integrity tests. IDDC carried out this with all those entities they carried out and they suggested some repairs. EAL we consulted, they have given report procedure. Here we introduced a new technology called EPFRP, which I will talk later. So structural integrity also is ensured here. These 2 reports were reviewed by EAL and finally they gave plant as fit for use and safe to operate. Next. So with that, that is how we did FFS for a fire damage case. Another case we carried out, it was a creep damage. There also we calculated and it came as a replace case. So we increased our monitor and making efforts to replace them. This is how we ensure the use the FFS for our integrity management. Now remaining life, based on material degradation fact, all these things we consider. As an initiative, what we have done is, for the entire refinery we carried out 32 units, third party remaining life assessment one time basis we have done. So this, as a third party, when they looked up, a lot of insights came because they did a comprehensive thing. Next. So all these entities were done, this is done. So plant-wide RLA also was carried out, including the pipelines. This is the second part of my presentation. Third one is stability certification. Factories Act demands that all the buildings in the factory, they need to be reviewed by a competent person and certified every 3 years. It is also applicable for plant, whatever technological structures are there, buildings are there. So this we carried out. In addition to that, OSD 170 also gives details of inspection, maintenance, repairs and rehabilitation of foundation structures. Why this is brought it here is, somebody also mentioned it elsewhere. The support is as important as the equipment that is sitting on it or the pipeline that is sitting on the support. Particularly in a fire damage case, if the support gives away, the entire equipment will collapse. So it is very important that the foundation is correct and fireproofing is exact. So that is a very important element in asset integrity. So using these things, we carried out all these things. Next. In addition, these are the entity tests, as I told earlier. Similarly, they do that for certifying, and repairs carried out, then they will give valid for 3 years. We took an initiative for OSD 160 for pipe, this guideline, to find out the gap analysis. As per OSD, what is the requirement, what is the current, because many units were constructed before OSD came into picture also. So the gap analysis also we completed and started restoring fireproofing or providing fireproofing where it is not there. So structure and fireproofing along with the equipment should be considered in its totality. Next. So in the process we also encountered some couple of new technologies which I thought will introduce. One is generally FRP coatings are 3 types. Glass flake epoxy that we use for acid tanks and all. Then EBFRP is externally bonded fiber reinforced. This carbon fiber reinforced we have used. When we brought this technology, actually we had no option to bring something else further. That time it came to us. We got it vetted by IIT Chennai also as a third party. And the other one is basalt fiber textile reinforcement cement mortar. This we got it approved by, vetted by our local Andhra University in the Vizag. Next. Here in a fire damage case unit, before the fire itself, we wanted to put some additional equipment on the technological structure. We found it is distressed. And load calculation gave that in no way we can put the equipment on top. And we had to repair the thing. So conventional method we estimated huge amount of concrete cement was coming. In a running unit, it is infeasible for us to do it. Then we came upon this technology. These are wraps, fiber wraps as well as laminates. These we used. You do surface preparation, epoxy apply, carbon wrap or laminate. If it is beams, you put wraps. If it is laminates, slab laminate. Columns, you put a wrap. Marble sand you put, then fireproofing, then anti-corrosive painting. Because this carbon wrap and all, if I put in a hydrocarbon environment, that is not, it is not meeting the fireproofing requirement. So additionally, we have put this fireproofing is an imported component we got. Next slide details are there. Around 40 mm thick we have put. That can withstand fireproofing up to, resistance up to 4 hours. Then after this, the structure vibration, because this is also mounting all the AFCs. Load carrying capacity increased as I have shown earlier, previously. Cost reduced by 2/3 and it is a feasible solution in a running unit. Go back once. You see that, no? That is dimensionally not much change. Is there very structural integrity maintained, but column strength increased by 50%. So I could put my new equipment on top, and a life of 20 years is given. Next. So this is for EBFRP. Next. Then recently we had to, as per Intelligence Bureau requirement, we have to increase the height of this wall. But this old wall, RCC, rock construction, stone construction is not having a lot of cracks and carrying capacity was also not there. So the proposal was to dismantle it, take away the stones and put a new wall from the grade. That was costing us around 12 crores. Then we thought this technology came. We put this basalt fiber textile. This is also a wrap on that. So you cement prepare, crack grouting and repairs in conventional way, mortar. Then you put anchors to the mat, basalt fiber, polymer mortar, and anti-corrosive coating. This is a good new wall that has come. And time saved, money saved. Next, no need for dismantling the old wall and transportation material. Load carrying. Step to slope based values are avoided. Cost reduced by more than 2/3. Easy to apply, and it is meeting the requirement of reduce, recycle, and reuse. Next, with this my 3 parts are over. If you permit, last part. Just to put in context of the presentation, we started in the morning, if you remember, the IAS officers, Mrs. Shukla, all these eminent speakers were speaking, and Mr. Gopalan, he also suggested certain things. From Mr. Sunil Kumar, he said housekeeping is a very essential in asset integrity. See, this is the lowest end of the spectrum. There is nothing hi-fi. But a very senior person in the ministry is talking, who has access to every energy asset in the country and is visited widely. I personally believe housekeeping is a must for asset integrity. In fact, I tell my people, before job, during job, after job, you do housekeeping. It will improve asset integrity like anything. Second thing, he talked about drone-based UTGs, energy sector to put satellite for real-time monitoring. That means drone in the Akash, satellite in the Antariksha. वहाँ तक he is talking about it, how to monitor in real time, and a dashboard. Definitely these are required, and my friend from Shell also has told about silos integration of different assets. So today's presentation different people have given. We all want to use new technologies. All these things we have to integrate, starting at the end of housekeeping up to real time monitoring using all the technologies. Must. Technology is a must, digitalization a must. One more interesting aspect I have found today morning, it came in WhatsApp to me. Google is now coming up with a solution where retina is scanned and it tells about your body, everything, whether you are likely to have a cardiovascular attack in 5 years or not, it will tell. Okay. And my friend in Dubai, radiologist, she is telling they are also having artificial intelligence to predict applicability of, occurrence of cancer in next 5 years or immediate. So such kind of technologies are